I, Dr. Atul Bhatnagar from Department of Chemistry, SRLS Government PG College, Kaladera, welcome you all in today's e-lecture, which is being prepared for the students of MSc final year. Our topic is from pericyclic reaction. Topic is symmetry in molecular orbitals and filling of electrons in molecular orbitals of conjugated polyene. How or what type of molecular orbital symmetry is shown by the molecular orbitals, and how these molecular orbitals are filled with electron we shall discuss in the second part. Now I am going to start first part, in which we shall discuss symmetry in pi molecular orbital. So we can say any pi molecular orbital that can exhibit or that can show only one type of molecular orbital symmetry. Two type of symmetry is available. Two type of symmetry is shown by the molecular orbitals. One is known as mirror plane symmetry and another is known as center of symmetry. If the molecule is showing mirror plane type of symmetry, then it is not in a position or it cannot show center of symmetry. If the molecule or molecular orbital is showing center of symmetry, then it cannot show mirror plane symmetry. That is due to the arrangement of the molecular orbital. So we can say no molecular orbital can show both type of symmetry. This we should remember. Now we shall start with the mirror plane symmetry. M symmetry or mirror plane symmetry. What is that? If molecules are arranged in this manner. What is this manner? One orbital is the mirror image of another. This is the orbital. This lobe of the orbital is having positive wave function, and this lobe of orbital is having negative wave function. If we put a mirror on the opposite this orbital, which is pz, remember this orbital is pz orbital of atomic orbital. So the another orbital is exactly mirror image of the first one thing, and mirror plane is perpendicular to the plane of molecule. If this type of arrangement is shown or this type of symmetry is shown by the molecular, then we say molecule has or molecular orbital has M symmetry. In molecule, some of the molecular orbital at particular energy level will be of symmetry, plane of symmetry, and some will show C2 symmetry. We will discuss in this lecture C2 symmetry also. So this is first type of M symmetry. What is this? How can we write it? If a molecular orbitals are arranged in such a way that one orbital appears to be the mirror image of another orbital, one thing, and mirror plane is perpendicular to the plane of molecule. So we can show this is the orbital, this is the second orbital, both are mirror image of each other. This mirror is perpendicular to the plane of molecule. This type of arrangement is shown by the molecular orbital is called M symmetry. If suppose this type of arrangement is not available, molecules are not mirror image of each other, then the molecule will not show any M symmetry. These orbitals may show or will show center of symmetry. What is center of symmetry? In center of symmetry, we see this type of arrangement. In this type of arrangement, if we draw a line from this point and reaches to the center line, and then the same line is extended on the other side of line plane and reaches to this point, then two things are to be noticed. One thing, distance traveled by this or distance traveled on the upper side of the plane is equal to the distance traveled below the plane, or we can say distance traveled from top of the lobe to line is equal to the line to top on other side. Similar is the situation here, traveling from this point reaching here, same distance is traveled on the other side to reach this lobe. So how this can be shown? This is the line. We have drawn this line. In this line, we can clearly see we have traveled from this point to this point and again to this point. Similarly, on the other side, we can also see we have traveled from this to this point and from this point to this point. Now, there is a point of intersection. Both the lines are crossing in the center of this line, line of plane. What is this? This is called C2 symmetry, center of symmetry. How can we explain it? Center of symmetry is a point on molecular axis. This is molecular axis. If we draw a line starting from an orbital on one side and extend it to the orbital on other side of the orbital of same wave function. This orbital is having wave function positive. This orbital is having wave function positive. If we draw a line from this point to this point, we can travel the same distance, but the wave function orbital is negative. So center of symmetry will not exist here. Center of symmetry will exist only if we reaches to the same wave function lobe. Distance traveled by one side of the line is equal to the another side. So this is the center of symmetry. These are the basic things we shall be using while discussing other topics in this chapter. Come to symmetry in pi molecular orbital of ethylene N13-butadiene. We have already discussed the symmetry, this formation of molecular orbitals in ethylene and 1,3-butadiene. First of all, we shall discuss the symmetry in ethylene molecular orbitals. At the time of formation of molecular orbital in ethylene, we saw two types of molecular orbitals are formed. One is bonding and another is anti-bonding. This is the structure of bonding orbital. These orbitals are present at lowest energy level, that is Xi1. What we can see, what type of symmetry is shown by these bonding orbitals? They are M symmetry type. So we have written symmetry is M. If the molecular orbitals are showing M symmetry, then it cannot show center of symmetry. So we shall say C2 symmetry is asymmetry. A. For symmetric, we shall use symbol S. For asymmetric, we shall use symbol A. And there is no node. What is node? If positive wave function is followed by a negative wave function loop, then they cannot interact with each other. They cannot combine. So there is a node. This line is shown by a node. This is positive wave function lobe, and this lobe is again positive wave function lobe. So there is no node. So number, we can say nodes equal to 0. Energy level is Xi1. M symmetry is symmetric, and C2 symmetry is asymmetric. Now we come to another energy level, Xi2 star. Xi2 or Xi2 star. This is anti-bonding molecular orbitals. In anti-bonding molecular orbitals, positive lobe is followed by negative lobe. So there is a node. This cannot interact with this one. So there is a node 1. This is energy level 2, which is existing, which is having one node. Now we come to symmetry. If we talk of M symmetry, this arrangement of molecular orbital is not M symmetric. So we say M symmetry is asymmetric. And C2 symmetry exists. So we say C2 symmetry is symmetric, represented by S, and M represented by A. So what type of symmetry in molecular orbital of ethylene is shown by this figure. At energy level 1, Xi1, it is M symmetric. At energy level Xi2, it is asymmetric. Similarly, we can also discuss 1,3-butadiene. In 1,3-butadiene, we draw following structures. At Xi1 level, all positive lobes are above the line and all negative lobes are below the line, plane of axis. In Xi2, this type of arrangement is available. One molecular orbital is having positive lobe above the plane. Another molecular orbital of ethylene is having positive wave function lobe below the plane. Yeah. This is the Xi3 at energy level 3. Plus, minus, minus, plus. So these two orbitals, they are having interaction. While these two orbitals they don't have interaction. So they will be having one node each side. So two nodes are available. This is Xi4. All wave functions are on the opposite directions. So every orbital set, or between the every two orbitals, there is a one node. Positive, negative, positive, negative. So it is having three nodes. Now we shall start from Xi1. Number of node is 0. M symmetry is symmetric and C2 symmetry is asymmetric. Xi2 at energy level 2. What type of molecular orbitals are present? There is one node. M symmetry is asymmetric and C2 symmetry is symmetric. At energy level Xi3, number of nodes are 2, 1 and 2. M symmetry is symmetric. C2 symmetry is asymmetric. Xi3, number of nodes are 3. M symmetry is asymmetric, while C2 symmetry exists. What we have observed in these observations, how number of nodes can be calculated. Simply n minus 1. N means energy level. Xi1. Xi n, Xi1. 1 minus 1, 0. So number of node is 0. Xi2. N, value of n is 2. So 2 minus 1 equals to 1. Number of node is 1. So you can calculate in either way. Up to 4, 5, 6, 7. Number of nodes present will be one number less than n. N minus 1. Second thing, if you observe Xi1, Xi3, that is odd number of wave function, odd number of energy level, Xi1 and Xi3. We are having M symmetry, C2 asymmetric, C2 asymmetric. If you observe molecular orbital at energy level having even number, Xi2, Xi4, then we are having M symmetry type is asymmetric, but C2 symmetry is symmetric. C2s, C2s, MA, MA. So what we can say in simple words, or how can we calculate we are on the same path or no, not? We can see or calculate number of nodes by n minus 1. If n number is odd, Xi n shall have symmetry with plane of symmetry, that is M, and center of symmetry will be asymmetry, C2, that is C2. And if we are having n number equals to even, then we shall have asymmetric with plane of symmetry, that is M, and center of symmetry will be symmetric, that is C2. This is all about the symmetry in molecular orbital of ethylene and butene. Now we come to the next part. How electrons are filled up in molecular orbitals. What are the rules? Filling of electrons in pi molecular orbital in conjugated polyenes. Conjugated polyenes means there should be even number of carbon atoms. Number of conjugated electron in the conjugated system should be equal to the rule given by Huckel, that is 4n plus 2 pi rule. Number of pi electrons will be filled up in the pi or molecular orbitals. So total number should not exceed or should be equal to 4n plus 2 pi rule. Number of bonding and anti-bonding molecular orbital will remain equal. 50% molecular orbitals will be formed of bonding type and 50% molecular orbitals will be converted into anti-bonding molecular orbitals type. Maximum 2 electron can be accommodated in a orbital, which we can say the filling will follow or abide by the Aufbau principle and Hund's rule of maximum multiplicity. If molecular orbital contains 2 electrons, then both electrons will be in a paired state. Unpaired electron will not be available if 2 electrons are present. Since molecular orbital will not degenerate in energy level, in any of the energy level. So we can say each energy orbital level, each energy level will contain only one molecular orbital. Energy level of pi molecular orbital is directly proportional to the number of nodal planes. How many pi molecular orbitals are present in at that particular energy level, that will be directly proportional to the number of nodal planes. These are some rules or some directions given for the filling of electron in pi molecular orbitals in conjugated polyene. These rules you should remember. Generally they are not asked, but you should know while filling the electron. With this, I conclude the topic. We have already gone through the symmetry, type of symmetry, how they are formed, what type of symmetry is present in ethylene and in 1,3-butadiene, and lastly how the electrons in pi molecular orbitals of conjugated polyenes are filled up. We shall take up a new topic continuing with pericyclic reaction. So I should in the last suggest you to subscribe this channel. There are no charges for subscription, but on subscribing you shall be getting a notification for uploading of the video. If you miss the video, you can go through it some other times. Video will be available with you, audio video aids will be available with you anytime, any number of time. You can review the lecture. Thank you.